Hey guys, Ketan again. Today we are solving another problem from the beginner level of CodeChef in C++. And the problem that we are solving today is small factorials. And the problem code is FCTRL2. Okay. So the problem statement is you're asked to calculate factorials of some small positive integers. Well, let's take a look at the input format with an integer t, and it is not greater than 100 and always greater than 1, greater than or equal to 1, denoting the number of test cases followed by t lines each containing a single integer n. Okay. And the output should be for each integer n given at input, display a line with the value of n factorial. Okay. So we are given the first one is test cases. We have 4 test cases and each one has an n value. So we basically have to give the factorial of this number. Okay. Yeah, so let's jump right into the solution. So first we are taking the test case t, and then int I equals to 0 less than t. Sorry for that. I plus plus. So we're going through each test case, and then we're taking the n value, int n, c in n, right? So we need to find the factorial of this. So how do we do that? We can define another integer n fact, which will be 1. Let's say let's take 1 for start, and while actually this should be fine. While n is greater than 1, in fact into equals to n, and then n minus minus. Okay, and at the last we are just outputting that cout n fact and the line 2. Alright, so what will happen here is, guys, so if any of you is not familiar with factorials, first of all, so let's take 5. Let's say the n is 5, n equals to 5. So we need to find n factorial equals to 5 factorial, right? So factorial is represented as exclamation mark. Okay, now 5 factorial is equals to 5 into 4 into 3 into 2 into 1. Okay, so if this is 6, we'll also have 6 here, right? You get the structure of that, right? So now what is happening here is, let's say the number is 5, n is 5, in fact is 1. So while n 5 greater than 1, so I'll just trace it so that you'll understand it. First of all, the n value is 5. Now n fact is 1, right? This will become 1 into 5, which will become 5. So n fact is multiplied with, so if you are not familiar with this kind of statements, this is basically same as equals to n fact into n. So yeah, so this can be written shorthandedly as this into equals to n. Okay, so this will make n fact 5, right, in the first iteration, and then the n will become 4. Okay, it started with 5, then n became 4, and n fact became 5, right? In the next iteration, this will be 4 because we changed it here, and then n fact will become 5 into 4, which is 20, right? Because it is multiplying itself with n. Okay, and this will become 3 again. Now this is 3, so this will multiply with 3 and give 60. Now it will go to 2, and then we'll get 2 here. 2 is still greater than 1, so we multiply with that, so it's 120. Now it's 1. Now it's not greater than 1, it's equal to 1, right? So when it's equal to 1, we don't need to go any further. We'll just break out of the while loop and just print the in fact. So what will be printed? 120, right? So that is how it works, and the 5 factorial is 120, right? So we'll just plug in the given test cases and see if it works. I always recommend doing this first before submitting. So we got 1, 2, 120 and 6. 1, 2, 120 and 6, right? So these are correct. Now we can submit it and see if everything is good. Okay, wow, I did not expect that. Okay guys, so what is happening here is when we put a really large number, like let's say if the n value is 20 or something like big like that, what is happening here is we are exceeding the limit of int and we are going into a long int territory. So it is basically resetting the number or going into like this negative numbers, so that is affecting the solution, right? So if we change that to long int, the n factorial, because that is the value storing the big numbers, right? So if we change that, it is still a problem. Let's try long int. So I just want to check it with this, if it is working or if it still gives an error. Okay, so we are basically overflowing the limit of what we have here. Right guys, so you have seen it, what these kind of solutions are resulting us, right? So we are basically checking what is happening when we are putting a larger number and it is resulting in an buffer, like overflow of the range of the long int. Even the long int can't store that big of a number, because the factorial of 100 will have like more than 100 digits easily, right? It can't store that big of a number. So to overcome that, what we need to do is basically take an array with the digits as each element in the array, and then we need to maintain that array after each multiplication, right? So this solution is a bit complex, but it's simple enough. I mean, it's complex in coding, but it's simple in the principle. Okay, it's the basic multiplication principle of adding carry to the next bigger place value, right? So we'll do that, and please try to follow me here. And if you have any doubts, don't hesitate to go to the comment section and type your doubts. Okay. Okay. First of all, we take the scene and we take the n, right? So this is all common till there, right? So now what we need is an array with a really big size, right? Integer array. Let's still say that as in fact of what should be the size. Let's put the size as something big, but the size is basically the number of digits that we estimate is gonna be inside the final answer, right? The factorial of 100 can't be more than 1000, so let's put 1000 right now arbitrarily. So we have defined an array with 1000 digits. Okay, so they're all initialized to 0 first. First of all, we'll initialize the value of n fact should be 1, right? In the previous we have seen that the n fact is 1. So what we do here is we put n fact of 0 equals to 1 first. Okay, now when we are multiplying, let's say I'll explain this outside of that. Okay, let's say we are multiplying 56 with 3. Okay, so the answer is 168. Now how do we get there? With normal multiplication, first we multiply 6 and 3, right? So we get 18. Well, we can put 8 in the ones digit, but we get 1 as a carry, right? Now we multiply 5 and 3, which is 15, and we add that carry to the 15, right? So that's 16. Okay, yeah, so even in the 16, 6 is in the next place and 1 will be a carry. Since we don't have any other digit, we'll add 0 with 1 and we'll put 1 as the next digit, right? So we're basically going up the ones digit, tens digit and the hundreds digit concept, and we have to do the same thing with the array here. Okay, right, so while n is greater than 1, we have to do the same loop, and will be decremented by 1 at the end of the loop. But inside the loop, what we have to do now is we have to multiply the n fact with n, and here we also need another variable named carry to store what the carry is, right? Initially it's 0. Now okay, we also need like what is the ending point of the current number, like the ending digit of the current number in the array. So we'll store that at some location, let's say I. Okay, I is already used. Let's say j. Okay, and what is j now? J is 0 because in fact of 0 is final digit. Now yeah, so for let's take another variable k equals to j, and k is greater than or equals to, guys, we'll just shift the array thing a bit so that it will be easier for us to do. And what we'll be doing here is we'll actually put, okay, we'll change it to size, right? So we'll put here size equals to 1000, in fact of size. Now we are actually storing this at the end of the array. Okay, size minus 1, and j will be size, which is 1000 minus 1. Okay, yeah, so what is happening here is instead of previously what we did was, in fact, will be like this: 0 0 0 0 0 and so on. And at the previously what we did was we put 1 here and all of these were zeros, right, until 1000 to 0. Okay, now instead of this, what we're doing is we're storing it in this format: 0 0 0 0 0 and so on, and the last digit is 1 here. Okay, So what is the benefit of doing this instead of doing this, right? So now we establish j as size minus 1, which is this 999, because indexing starts from 0. The first element is indexed as 0, right? So that's why we are using the minus 1 here. So when we have to increase this, we can just multiply with this and then go through each place. But in this case, when we do this, we have to shift the number to the right if we have a carry, or we have to go a place up. Like in the case of 56 into 3, first we get 18, right? So we get 8, so this will become 8 then. But then we also have to multiply with 5 5 3 is a 15, so we have to change this here to 8, and then we'll be adding 1, so this will become 16, right? So we have 6 here. Now we also have 1, right? So we need to again shift this to 8, and then this to 6, and then this to 1. Okay, so there will be a lot of moving the numbers to the right. Okay, so that will be stupid to do. So what we'll be doing is, instead of that, what we'll do is, here let's take the same case here. So first of all, 6 is 18, so we get 8 here, right? Okay, okay, let's put it like this, so you can see what's happening. So we get 8 here, right? So we got 1 carry, and 5 3 is 15 plus 1 is 16, so we can just change this one directly. We don't need to shift anything, and then we got one more carry of 1 that will be put here. Okay, so we got the 168 right away. Now the j will keep decreasing, because this is 999, right? So we need to go to 998 and 997, so this will be j at the end. Okay, so by using j and the array, we can just easily access this, right? So this is basically what's going on here. So so k equals to, actually we have to take the size minus 1, because we are starting from the end, right? K is greater than or equals to j, k minus minus. Okay. So now let's say we have so the in fact is currently in this state, right? So let's say the n value is okay, and let's say the n value is 5. So what we have to do now is 5 into 4 into 3 into 2 into 1, right? And it should give us 120. But before that, let's go step by step. 20 into 3 into 2, so that should be 60 into 2, so that should be 120, right? This is how it breaks down, right? Right, so this is how it breaks down. Now let's say the n value is 5. So what do we do now? We actually take the n fact of k into n, right? Let's take an integer x here and multiply that, so we get 5 into 4. Sorry, in fact of k is 1 right now, and then we multiplied it with 5, right? So we got 5 here. In fact of k will be changed to x percentile 10, right? And then x should be divided by 10, Okay, and now carry. Okay, just a second. Right guys, so we also have to add something here, which is C, or it's actually carry. Why? Well, I'll tell you, just a second. I'll just change this int above x. Okay. Well, we whenever we are multiplying, there's high chance that we'll get a carry. So we need to also add that to the the digit, the last digit, right? So yeah, we'll add the carry there. Right now, we need to change the in fact of k, and that will become x percentile 10, right? And then we also need to change the carry, which will become x divided by 10, right? Because we are in the case of let's take 16 to 2, right? So we multiplied 0 with 2, and the carry is 0 because we have cleared it here. Now, so what is the value? It's 0, right? So we just put 0 in the in fact of k, which is the last digit. We put 0 here, and now the carry should be we can put that by using the percentile because it's the last digit, and then the carry will become, what will be the carry? Carry equals to 12. Carry should be 12 now because we have to divide it with 10, because we have two digits here. We have to take it and carry it with us. Okay, right. So this is here, and then after all the iterations, we are still left with some carry, right? uh, Even in this case, we saw that we are left with a carry of 12, right? So what do we do with that? We just push it onto the array, right? Because we have taken care of all the previous carries. We just push it onto the array. How do we do that? While carry is greater than 0, we just push it into in fact of, which start with the in fact of j, in fact of j minus minus equals to, okay, actually no, minus minus j equals to, because we have already hit the j, which is here. We need to go beyond that, and then we need to push the c into that, right? The 2 should be pushed here, so we push c percentile 10, and then c is divided by 10, right? So while the carry is not 0, we keep pushing that, right? So we push it until it becomes 0, and after pushing 1, it becomes 0. Now we just get out of that, and we just decrease the n, and then we go back to processing it again. Yeah, so I think this should work. And after all of that, for int k equals to size minus 1, k less than or equals, sorry, k greater than or equals to j, k minus minus, we just see out in fact of k, and after all of that we see out an end line. So let's see if this works. I really hope it does. Okay, I'll just check if this is correct, right? Excluding the zeros, if this is everything else is correct. Okay, we need 10 factorial, right? 10 factorial is, yeah guys, so I just changed the starting and ending points of k. So this was the problem. This I didn't change any of the actual logic. Only while displaying it, I messed up in the for loop there. So I started from j and I ended with size -1. Okay. Previously I started with size -1 and went in the reverse order. So that was the problem. So I just started with j and I ended with size -1 because that's how we stored it in the array, right? So I didn't change any of the core logic. That's all correct. And by changing this, I just changed that, and with that, if I run this now, I get these values, and these are actually correct. So how do we know that? We can just check. 10 factorial is 3628800, and then 20 factorial is 243290, and so on, right? So we'll just submit this and see if it works. It should work because this is scalable to like 200. That's the limit there, and there we go. We got the correct answer, and the time is also like 0.0 seconds, right? So this was really lengthy, but if you have any doubts, please don't hesitate to put it in the comment section, because this was kind of a bit complex in coding it, but I think the logic is fairly simple. The coding part is a bit complex, but I think you can understand it if you put some time into it. Okay. Yeah, thank you guys. Hit the like button if you liked it, and share it with your friends. Subscribe if you want to see more content. And it's been like an hour that I had to figure this out, because in Python we don't have the problem of storing storing a bigger number. We don't even think of that. So in C++ it's different, and long int couldn't even store that kind of values, but Python just does something and stores any seemingly any size of integer. So that's why we didn't have any problems while I was doing the same problem in Python. So yeah, thank you guys. See you soon.